In this lecture, I'm going to be discussing actors that can help you add a realistic looking atmosphere and clouds to your level. So let's say I start out with a new, completely empty level. I'll add in a plain mesh for the floor and a couple of pieces of furniture, and then I'll add a directional light actor to represent sunlight. So notice that even though I added a directional light for sunlight, it still doesn't look like we're outdoors. So I'm going to show you two different ways you can make it look like that. The first way is the older method of doing it, but I still want to show you because those actors are still in the engine and that's still the method that is used for the default level. Alright, so the old method involves using an atmospheric fog actor for the atmosphere and a sky sphere actor for the clouds. So first, I'm going to add an atmospheric fog actor to the level. So I'm going to go up to the Create menu and then down to the Visual Effects category, and then I'm just going to drag this atmospheric fog actor into my level. And right away you can see that this looks much better. I have a blue sky, I have a sun disk, and things get a little foggy when they are far away in the distance. So by default, the sun disk of the atmospheric fog will appear on the horizon, giving a look of sunrise or sunset. But watch what happens when I combine my atmospheric fog actor with my directional light actor. If I select my directional light actor, then go over to the Details panel, and then go down to the Atmosphere and Cloud category, there will be a property called Atmosphere Sunlight. If I check this property, the atmospheric fog actor in my level will use the rotation of the directional light actor to determine where the sun disk should be placed in the sky. So now that I've checked this, the sun disk is up here, because it's looking at the direction that the light rays from the directional light actor are set to hit the Earth, and then calculating where in the sky the sun should be for that to make sense. So now if I switch the rotation tool on my directional light actor and change the angle of the light rays, it will change the location of the sun disk in the sky. Alright, and there's actually a shortcut specifically for the directional light actor that makes this easier. If you hold down Control L while nothing is selected and then move the mouse, that will also change the rotation of the directional light actor and thus move the sun around in the sky. Alright, and now to add clouds to the sky, the old way was to add a sky sphere to the level. To access the sky sphere actor, I'm going to need to open the Place Actors panel from the Create menu. And then I'm going to go up to the search bar and search for Sky, and then drag in this BP Sky Sphere actor. And now I need to go over to the Details panel and set the directional light actor property to the directional light that is in my level. Alright, so now you can see that the Sky Sphere actor has added these nice looking clouds to the level, and this looks like a realistic Earth atmosphere. Okay, but like I said, this is now considered the old way of creating an atmosphere, although it is still used for the default level. The new way of creating an atmosphere is the method used in the time of day level and uses the sky atmosphere and volumetric cloud actors. So I'm going to delete the sky sphere and the atmospheric fog actors, and then go up to the Create menu and down to the Visual Effects category and add a Sky Atmosphere actor to the level. Okay, and keep in mind that just like with the atmospheric fog actor, you will need to have the atmosphere sunlight property of the directional light enabled for this to look correct. Alright, so one of the advantages that the sky atmosphere has over the atmospheric fog actor is that it can more accurately render what the sky should look like at different times of the day. So I'm going to make sure nothing is selected and then hold down Control L to change the sun's location in the sky. And you can see that as the sun disk gets lower in the sky will gradually turn to sunset and then to nighttime. Alright, so now let's take a look at some of the properties of the sky atmosphere actor. The first category I want to look at is the atmosphere category. So first, the atmosphere height property is pretty self-explanatory. This is the height in kilometers of the atmosphere. In other words, it is the distance from the surface of the planet to outer space. Okay, so another advantage that the sky atmosphere has over the atmospheric fog actor is that it allows for a seamless transition from the ground to outer space. Alright, so to make this demonstration not take forever, I'm going to set the atmosphere height a lot lower, down to 5 kilometers. And then I'm going to set the camera speed and the viewport to the maximum speed. And then I'm going to right click on the mouse and press the E key so that the camera in the viewport starts moving straight up. And as we move higher and higher, you will start to see the curvature of the Earth. So sorry flat earthers, but in Unreal Engine, planets are indeed round. And then as we continue to move higher, the atmosphere will gradually get thinner and thinner until it disappears completely and we reach outer space. Alright, so that's pretty cool, and if you were developing a game that included space travel or something, this feature would really come in handy. Alright, so the next property in the atmosphere category is the multi-scattering property. This setting determines how much sunlight should appear to scatter or bounce around in the atmosphere. With this property set to the maximum of 1.0, which is the default, the effect will mimic the average amount of scattering in the Earth's atmosphere. As you set this property's value lower, this effect will lessen until it reaches a value of 0, at which point it turns off completely. Alright, so now let's go up and take a look at the planet category. The first property, transform mode, is used to define where the bounds of the planet should be considered to exist relative to the location of the sky atmosphere actor. So with this set to the default value, planet top at absolute world origin, the surface of the planet, and thus the bottom of the atmosphere, will be considered to be at the world origin of the level, which is located at coordinates 0, 0, 0. When this value is set, moving the sky atmosphere actor has no effect on the location of the atmosphere in the level. When this is set to planet top at component transform, the surface of the planet / bottom of the atmosphere will be considered to be at the location of the sky atmosphere actor. So in this case, moving the actor will change the location of the atmosphere in the level. When this is set to planet center at component transform, then the center of the planet, not the surface, will be considered to be at the location of the sky atmosphere actor. Alright, and then the next property is the ground radius property. This property is used to define the size of the planet that your level exists on. It's the measurement in kilometers from the center of the planet to the surface of the planet. So this is used to calculate the location of the surface of the planet when the transform mode property is set to planet center. This also helps to accurately calculate the curvature of the planet when transitioning to and from outer space. Alright, and then the last property in the planet category is ground albedo. So going back to the scattering of light in the atmosphere that I discussed earlier, some of that light is due to the reflection of the light off the surface of the planet back into the atmosphere. Depending on the qualities of the surface, the light will be reflected back at a certain wavelength and thus color. So the ground albedo property will determine the color of that light. The overall effect of all this is that the property can be used to change the color of the sky. Alright, and then down under the atmosphere category is the atmosphere Rayleigh category. These properties deal with Rayleigh scattering, which is the scattering of light in the atmosphere due to small particles such as air molecules. So probably the most common example of Rayleigh scattering in the real world is how the sky appears redder at sunset. So blue light scatters more easily than other colors. The upper atmosphere is less dense, meaning it has less air molecules than the atmosphere closer to the surface. So at noon, when the sun is high in the sky, its light is traveling through the less dense air, and thus less of the blue light gets scattered and more of it gets through to the surface. At sunset, when the sun is on the horizon, its light is traveling through much denser air with more air molecules that scatter more of the blue light away. The result is that a lot more of the other colors get through relative to blue light, and so the sky will look more yellow, orange, and or red. Okay, so if I hold down Control L and move the mouse until the sun is low in the sky, you can see this effect happening as the sun gets lower. And so the Rayleigh scattering scale property will determine how pronounced this effect is. Lower values mean a less dense atmosphere and thus less light is scattered, and higher values mean a denser atmosphere and thus more light is scattered. So as I change the value, the colors of the sunset will change. And then the next property is used to set the color of light that scatters the most easily. As I mentioned, in the real world this is blue, which is the default. But you could change this to another color, say red, and then you would have red skies with blue sunsets. And then the final property here, the Rayleigh exponential distribution, is just used to specify how high up in the atmosphere you have to go before the air becomes less dense. Alright, and so while Rayleigh scattering involves light scattering due to smaller particles, such as air molecules, Mie scattering involves light scattering due to larger particles, such as dust or air pollution. In this type of scattering, light gets absorbed, causing the sky to appear hazy. So the higher you set the Mie scattering scale property, the hazier or foggier the atmosphere will appear. Turn it all the way up, and your level will be foggier than your brain on one of Mario's magic mushrooms. Seriously folks, speaking from experience, if Mario or Luigi ever offer you some mushrooms, just say no. At least I think that was Mario and Luigi. I ran into them on a street corner downtown, so who knows. So anyway, you can use this feature to mimic the haziness of a desert during a sandstorm, or the smog of a polluted city, or just regular fog. And then there are several other properties in this category that can help you fine-tune exactly how you want it to look. Alright, and then the last category I want to look at is the atmosphere absorption category. So this is similar to the Rayleigh category, and basically you use the absorption scale property to set how much light gets absorbed in the atmosphere, and the absorption property to set which color gets absorbed the most. So this is just another way of controlling the overall color of the sky. Alright, so that's the new way to create an atmosphere. Let's look at the new way to create clouds using the volumetric cloud actor. So I'm going to go to the Create menu, and then Visual Effects, and select Volumetric Cloud. So now we have these clouds here that are a bit more detailed and realistic looking than the clouds created by the sky sphere. Also, unlike with the sky sphere, with the Volumetric Cloud actor, you can customize the appearance of the clouds. So let's take a look at some of its properties. Starting with the layer category, the first property is layer bottom altitude. This simply specifies the distance from the ground in kilometers that the cloud should begin to appear. So you can see as I slide this value higher, the bottom of the clouds gets higher and higher in the sky, and as I move it lower again, the clouds get closer and closer to the ground. The next property, layer height, specifies the distance from the ground in kilometers that the clouds should stop appearing. So if I move this value higher, you can see the top of the cloud layer reaching higher and higher into the sky. And so if I set these two properties back to their default values, with the clouds starting 5 kilometers from the ground and ending 10 kilometers from the ground, the total height of the cloud layer will be 5 kilometers. Alright, and then if you look down here, you can see that this has a planet category just like the sky atmosphere actor. So you can set the planet radius in this actor as well. But keep in mind that this value will only be used if there is no sky atmosphere actor in the level. Otherwise, the value in the sky atmosphere will override whatever value is set here. And then the ground albedo property for this actor determines the color used to light up the bottom of the clouds due to the light reflected back from the surface. Alright, and then the next property is what really gives the volumetric cloud actor its flexibility, and that is the material property. So the overall look of the clouds is specified by the material that you set here. Unreal Engine includes a default material here called Simple Volumetric Cloud, but this gives you the ability to swap that material out for another one that you download or create yourself. So this allows for a wide variety of different looking clouds that can be used in your games. Okay, and then there are various properties on the directional light actor that will affect how its light interacts with the volumetric cloud actor. So I'm going to select my directional light actor and then scroll down to the atmosphere and cloud category. The first of these properties, atmosphere sunlight, we've already seen. So just like this property needs to be enabled for the light to affect the atmosphere, this must also be checked if we want the light to affect the clouds. The next property, cast shadow on clouds, determines if the light from this actor should produce shadows on the clouds due to the meshes in the level. So with this property disabled, if a plane flew between the sunlight and a cloud, you would not see the shadow of the plane on the cloud. But if this property was enabled, then you would see the shadow of the plane. The cast shadows on atmosphere property is just like the previous property, except applied to the atmosphere rather than the clouds. Okay, and then the next property is cast cloud shadows. So while the cast shadows on clouds property determines whether or not other objects in the scene should cast shadows on the clouds, the cast cloud shadows property is the reverse of this and determines whether or not the clouds themselves should cast shadows on the other objects in the scene. Or a simpler way of thinking of this is that this property simply determines if clouds should block sunlight or not. So with this property disabled, a heavy cloud cover doesn't cause the rest of the level to look any darker. But with it enabled, as you can see, the environment does look darker, just like when the sky is overcast in real life. Alright, and then the next property is the cloud scattering luminance scale. This sets the color of the light that gets reflected off the clouds. So basically, this can be used to set the color of the clouds. And finally, I want to take a quick look at the skylight actor again. So as discussed in the previous lecture, the skylight actor has this property real-time capture. When this property is enabled, the skylight will take into account the sky atmosphere and volumetric cloud actors when calculating how its light should render. So if you have a skylight in your level and also a sky atmosphere and or volumetric cloud actor, you will most likely want this property enabled. Alright, so now you know both the methods of creating an atmosphere and clouds in Unreal Engine, and that will conclude this lecture.